Hi, everyone, and welcome to our webinar, How to Modernize Your Applications and Drive Business Value with Amazon Aurora. My name is Chuck Edwards, and I'm the Global Lead for AWS Database Partners, and thanks very much for your time today. So we all know that more and more business models are embracing the cloud, from SaaS applications like Salesforce to new and innovative business models like Airbnb and Netflix. The cloud is becoming a more ubiquitous part of application development and delivery. And customer adoption of the cloud has been so rapid and so strong that in 2017, as you can see from this quote here, IDC reported that all ISVs who want to stay relevant to their customers need to have some sort of cloud strategy or adopt the cloud in some way. And backing up IDC's assertion, we see additional data from Gartner. Gartner reports that 28% of spending within key enterprise IT markets will shift to the cloud by 2022, up from 19% in 2018. And they also report that by 2020, all new entrants and 80% of historical software vendors will offer subscription-based business models as well. And so what does this mean if you're an ISV? So if you're an ISV thinking about your move to the cloud, there's a few things that you can think about. At AWS, we see successful ISVs, those that are growing their business in the cloud is what I mean by successful, take a more modern approach to software development. And this is an approach to designing, building, and managing applications that enables faster innovation and increased customer responsiveness. The best practices of modern application development arose from our experience serving millions of customers and building applications for Amazon.com. And we've observed common approaches that enable our customers to increase agility and build better applications that support the success of their businesses. So why are ISVs modernizing applications on the cloud? They're rethinking their applications because the cloud lets them move faster and creates a lot more value for their customers at a lower cost. Things like pay-as-you-go pricing and on-demand infrastructure mean that ISVs don't have to pay for more than they use, which are savings that can then be passed on to their customers. They can also build in global resiliency and durability without paying expensive license fees for disaster recovery and high availability features for their software. And they can scale globally as fast or as slowly as they want without deploying hefty capital expenditures, not just for hardware, but upfront licensing costs as well, keeping innovation high and costs low for their customers. So while different ISVs approach these practices from different starting points, we do see some commonalities. One of the most common starting points is to move away from the expense and restrictions of commercial databases, which often increases customers' application cost of ownership while adding little actual business value. ISVs who can avoid these cost restrictions have an advantage when considering the global market of millions of AWS customers. Because customers still expect performance, availability, and durability, but they don't expect to purchase additional database licenses for these behaviors. Customers expect ISVs to support their own modern development practices as they move their infrastructure to the cloud, and they definitely look for flexibility and speed of deployment that's difficult or impossible to achieve on-premise. Commercial databases specifically present some fundamental challenges when considering a cloud deployment strategy. Scaling and agility is limited to hardware availability, location, and even license availability and costs. Imagine a customer deploying your software with single points of failure just because they don't want to spend additional money on database licenses. And as customers move to the cloud, on-premise database solutions often don't natively integrate, forcing customers and ISVs to build or buy the integration that they need. So we received a lot of feedback from customers and from ISVs who listen to their customer about what they really need in cloud-native database solution. They tell us that commercial databases like Oracle and SQL Server have lots of amazing features, but they come at a really high price, many times as add-ons and not included in the base product. And ultimately, these costs, whether they're used or not, must be passed through to the end customer, raising the total cost of ownership for an ISV's application without adding direct business value in many cases. As customers and ISVs alike rethink their applications for the cloud and AWS, they've made it clear to us what's important. They don't want a huge list of features that they may or may not use. They want speed of deployment, hyperscale performance, cloud integration, and they definitely don't want to pay huge upfront licensing and punitive ongoing support costs just to run their business applications in the cloud. And as we can see from this data, again from IDC, they're clearly showing us that relational database in the cloud is projected to far outpace on-premise deployments. By 2021, 34% of worldwide relational database systems will have moved to the cloud as to 2.6% on-premise. And this is a projection, but this is definitely showing the trend as seen by IDC. So this growing trend and customer feedback is why we built Amazon Aurora, which delivers the performance of commercial grade databases with the pricing, freedom, and flexibility of open source databases. Amazon Aurora is a MySQL and Postgres compatible relational database built for the cloud that combines the performance and availability of high-end commercial databases with the simplicity and cost effectiveness of open source databases. Aurora has 5 times the performance of standard MySQL and 3 times the performance of standard Postgres with the security, availability, and reliability of commercial grade databases at 1/10 the cost. Aurora is also fully managed with repeatable operational tasks like provisioning, patching, backups, and even automatic failover to secondary sites. Finally, Aurora is an integrated cloud-native database with features like Lambda and S3 integration and serverless deployments, where the database instance computing power can grow and shrink on demand. Customer reaction to Aurora has been overwhelming, making it the fastest growing service in the history of AWS. In 2015, Aurora already had thousands of customers, including enterprises like NBC Universal, PG&E, and the United Nations. In 2016, the number of customers grew by 3.5 times, with household names like Netflix, LexisNexis, and Ticketmaster joining the list. And in 2017, the number of customers grew by 2.5 times, with organizations like Expedia, NASDAQ, Verizon, CBS Interactive, Dow Jones, and Hulu running their business critical workloads on Aurora. Today, we have tens of thousands of enterprises and startups running their applications on Aurora. Using Amazon Aurora as a foundation for ISV software provides a number of strategic benefits. First, AWS has millions of customers, and they consistently choose solutions that do not require purchase and maintenance of commercial databases. Second, removing the cost of commercial database license can reduce customer TCO for ISV software, regardless of a SaaS or single tenant deployment model. Third, eliminating these heavy upfront costs from ISVs and their customers, embracing the pay-as-you-go resourcing model opens the door for more flexibility in deployment and pricing options that customers expect in the cloud. And finally, Aurora's native integration with other AWS services opens the door for innovation that really matters to ISV customers, including AWS Analytics, artificial intelligence, and machine learning services. And it's not just cloud-native startups embracing Aurora. Many familiar ISVs like BMC and Infor offer Aurora-based or Aurora-compatible versions of their software. So to help the growing community of ISVs who are modernizing their offerings with Amazon Aurora, in 2018, AWS launched the Database Ready Program. Database Ready provides the people, tools, and support that ISVs have asked for to help them deliver a cloud-native Amazon Aurora-based offering to their customers. The program mission is to help ISVs build profitable cloud-native solutions faster with Amazon Aurora. The program provides some standard benefits. While building, ISVs have access to technical support from both AWS and our Database Ready system integrator partners, as well as service credits to help offset development costs. When an application is ready for customers, we'll feature on the Database Ready webpage, and we also may make it ready for launch through AWS Marketplace if that makes sense for the ISV. Finally, Database Ready can help accelerate net new and legacy customer adoption of your Aurora platform through marketing development funds and go-to-market promotion and support. Taking a closer look at some of our Aurora-enabled ISVs, Alfresco found they could scale 10 times on Aurora MySQL over their self-managed MySQL deployments. Alfresco now scales to over 1 billion documents with a throughput of 3 billion documents per hour on their Aurora MySQL deployment. And BMC recently certified their Remedy application to run on Aurora Postgres. BMC Remedy customers who are paying thousands or tens of thousands of dollars for SQL Server or Oracle licenses can now deploy Remedy on AWS and drop those licensing costs.
Thanks, Chuck, for giving us this opportunity to talk about how DB Best can offer ISVs a great solution to help them in their migration. I'm Bill Ramos, Chief Technology Storyteller at DB Best. What does that mean? I'm responsible for all the content that DB Best provides, along with providing our team of experts with the latest and greatest insights from cloud vendors like AWS. And so what I'd like to do is talk to you more about DB Best and what we have to offer for you. First off, at DB Best, our bread and butter is all about modernizations. That's how we became a company. It started out with doing database migrations, and since then, we've moved, kind of our customer base to this whole idea of new solutions, like how do you build new applications on top of those databases that may have been migrated. And then lastly, we want to make sure that we have a great managed service for you to help you keep your systems up and running, whether it's the databases, whether it's the cloud, whether it's the infrastructure, integrating with your deployment practices. And what makes us unique are the team of experts that we have, called the people, the processes that we've developed doing database migrations, development, not only development for our customers, but also packaged software for our customers, and products and platforms which we actually develop to help mitigate risk in the migration process, in developing your solutions, being able to provide a testing platform, and also do monitoring of your environment to make sure it's a healthy environment, integrate with trouble ticket systems and things like that. So it's those three things that I think give us a unique advantage as an AWS partner to help you as an ISV in your journey. To help you with your cloud adoption, one of the things that we do is kind of help you understand kind of your current state and how it's performing in your current environment, and use some of the monitoring tools that we've developed for our customers to help right size their workloads or help understand what SQL is going through their system in helping you in that migration process, not only for the database layer, but for the application layer. And like I said, we've done this a lot. We are an advanced partner with AWS. We have done more migrations from on-prem to Amazon's database platforms using the schema conversion tool than any other partner in the world. We have that unique experience. We have a great set of blog articles you can go at on our website at dbbest.com to help understand our insight into the schema conversion tool. And we are experts in the database migration service. And we've kind of helped, as one of those early adopter partners of AWS, help fine-tune some of the things that database migration service helps you in moving large databases to the AWS platform. So our strength on the AWS platform, our vast experience in being able to help customers migrate their databases there, and the ability to provide you with an understanding of what it will take to actually run that environment on the AWS cloud are going to be critical as part of the overall migration process. But the thing that we want to focus on is that there are three things that you really need to worry about from an ISV's perspective. The first one is that initial upgrade migration and what we call a unification effort. Everything that you've heard up to now is all about, oh, let's upgrade, let's migrate. But when it gets down to it, you have to think about what are the next steps after that. Now, in terms of unification, what that means is that you may have, say, your application running on Oracle today within your data center as a service, or maybe you deploy Oracle as part of your solution to clients. And the customer is familiar with that environment. So one of the things you can do is actually do, say, a lift and shift operation of your Oracle database to work on, say, either Amazon RDS for Oracle, or Oracle running on, say, EC2 instances, depending on your needs. But more importantly, you'd really want to take advantage of the Amazon Aurora for, say, Postgres or MySQL for that workload. And so what you want to think about is how you want to maybe abstract the database layer from your application so that it can actually work on either environment. If the customer likes the Oracle, they have their staff trained on it and want to continue to use that, they can do that. But if they want to take advantage of the great features that Chuck had talked about in terms of Amazon Aurora for Postgres or MySQL, they can do that too. And so essentially, we end up working with ISVs to help them a lot in their overall development process and optimizing for the development process to provide that abstraction layer, then say we might be optimizing for the actual target itself. So when you think about what it takes to do that initial port, we may want to look at to what extent you want to perform this unification effort. Second step is, okay, you've got this great product now working on the AWS platform, and it's using Amazon Aurora as its database. How do you take your current customer base and upgrade/migrate them from their earlier versions to the AWS platform? And a lot of times you forget about this. You spend all this effort in trying to do the upgrade, but you have to think about, okay, now I've got these customers. What do I have to do to help move the database? How do I move their customizations that they've made to the application? What are the kinds of things that you need to think about, in terms of they were running on-prem, how do you make sure it integrates with their on-prem network and deploying it on the AWS environment? And so you need to really understand kind of that upgrade process after you've done this whole unification. And then finally, it's developing or having the need to develop a practice for actually getting the customer to do the upgrade. So what's the checklist of things that you have to go through to get the customer from their old solution to the new solution, so they're taking advantage of all the great capabilities of AWS as painlessly, as frictionless as possible. Okay, so I want you to keep those things in mind when you're looking at your migration path to the cloud. Now, in terms of the migration path, the first two items that we had talked about, the initial migration and even helping customers migrate there, DB Best has developed this 12-step migration path that applies to the database and application migration pattern. And what we show here is the general level of effort that it takes to perform these different actions. So for example, this is based on years and years of experience in migrating databases. Now, your experience in doing this might be completely different, but because we know all the ins and outs of the migration tools, the things to look for, this is kind of our pattern for where we see the levels of effort are in doing the migration. Let's take a look at each one of them, because the most critical one starts with a future state architecture design. What this typically does, and I'll walk through kind of an example that I personally did on a recent customer engagement to help them move to AWS, is we started out by understanding their current architecture. In this case, they had a bunch of Kubernetes cluster that were connecting to an Oracle database or Postgres database, and they wanted to know kind of what it would take to get it to AWS because they didn't have that cloud experience. So what we did is kind of did an overview of what their environment looked like, what their development process was like to deploy to their current on-prem implementation that they had, and then tailored a solution for them on what it would look on AWS. And that included not only the deployment of the Kubernetes cluster using the services that AWS provides, but the database layer, and then what it would take to optimize their database layer for Amazon Aurora, and in this case, for Postgres. Even though the platform was, they already done a lot of the hard work to do the abstraction, but there are little nuances that they had to adjust for in making sure that the version of Postgres that they were working on would work on Amazon Aurora. The other thing that we helped them on is a design of how to actually deploy that solution in the AWS marketplace. so that way their customers who are doing new deployments could go ahead and just go to the marketplace, go to the solution, and fire it up. And so what we did as part of this future state architecture is actually did a mini proof of concept where we took a very small subset of the containers that were associated on their cluster, created a deployment package that could deploy on the marketplace, and did a private deployment and showed them a private deployment on the AWS marketplace. And so that gave them the confidence that yes, we can go ahead and take our application, package it up. So these are the kinds of things that you see that we'll do to help you in the future state architecture design. And this is where we establish that rapport between our development team and our architects with your development team and your architects to make sure that we're all on the level footing and establishes the framework for the rest of the solution. The other thing that we want to look at are the other steps that are there, and just kind of go through briefly on what these all entail. Database schema and object conversion. Typically, we'll use tools like the AWS schema conversion tool to actually run it against your database schemas, look at the reports that come out of it, match the patterns that we see out of the reports that we've developed in-house to solve some of the issues that might come up. For example, there may be some issues that your application on Oracle did row-level locking, whereas maybe that feature wasn't immediately available in Amazon Aurora for Postgres. We've worked through these kinds of patterns before, and we know how to solve that. And so we look at ways to optimize that process in the conversion. The other thing that we do is we use tools like the schema conversion tool again to look at your application directories and look for what I'll call the dreaded SQL statements that are embedded in your application code. Admittedly, there are a lot of people that still write applications in Java or .NET or whatever it happens to be where they embed the SQL statements in there. That's the kind of thing that we look at as part of our unification effort, trying to separate out the database, creating a database abstraction layer and finding out where the application are doing what I'll call the naughty things, and help you in that overall conversion. The other thing you need to think about are all the kinds of things that take place in your application, say for extract, transfer, and load. Are you taking data from other sources other than the pure database? You need to make sure that those all work in the AWS infrastructure. So a lot of times we'll take the scripts and ETL jobs and look at capabilities that are available in AWS Glue, for example, or even Lambda functions to help you perform these types of operations. Likewise, you have to think about if you have embedded reports in your application. We recently had a customer, for example, that had an application that used Crystal reports from SAP, and they needed to translate all those reports from Oracle over to their target environment. And in that case, we saw how those reports looked, and we actually built an additional layer of automation. And this is why I say it's great to have us as a development team, because we think about these platform pattern examples. And we came up with a very easy way to automate thousands of Crystal reports to translate them to actually migrate over to the new platform by altering the connection string information and actually translating the embedded SQL statements in those reports. In addition, you may have integrations with third-party applications. These could be, for example, software as a service applications and things like that. You need to make sure that those will all continue to work on top of your application. Another thing you want to think about is, especially as an ISV, what things the customers may actually have done to integrate with their database. And did you have an abstraction layer on that? Or were they able to just willy-nilly go into the database and alter the design, which you hope not. It's a maintenance nightmare. But assuming you had a nice API on top of that interface, you want to make sure that if they integrated with third-party applications, that you actually work with your customers, understand what those are, and provide a test framework to make sure that the integrations will work when you actually deploy it on the customer site. There's going to be the whole aspect of data migration, step number 6. What this is all about is, okay, you've with your test environments and things like that, obviously you're going to need to migrate the data over there, but you're going to need to develop a plan for your customers on how they're going to do the database migration, or the actual database data migration from the database into the new platform. Now, this is mainly from an ISV perspective. There's, of course, the functional testing and all the things that you have to do with fixing defects and performance issues and stuff like that. This obviously plays an important part. One of the things we typically do is we have a capability and a tool that we call our DB Best Database Migration Platform, which we can deploy in your environment to actually generate test cases for stored procedures, queries in your environment, where we can test them on the original platform, say your Oracle database, and then look at the results of that after the translation on your Amazon Aurora database. And that way you can develop this automated test framework based on the code that we generate out of our database migration platform, work that into your DevOps environment or your integration environment, so on. Now, in terms of kind of like as you're getting ready to do kind of those last minute things, now, ideally performance testing is kind of built into your continual integration framework. You'd have a set of performance benchmark tests that you would run against your environment. But we call that out here specifically to make sure, hey, you better think about this. Because you want to make sure, of course, that running on the AWS platform, you're going to give a customer a better kind of feel for the speed of the application over, say, what you had before in your prior release. And then again, like I said, we want to do all this inside of your environment. So we work very closely with your DevOps team or your deployment team on coming up with the processes that will work not only for the migration of your environment, but also help you in the integration and deployment at the customer site. Like any component, we offer a variety of training programs to help ramp up your team to understand the platform, not only from the database perspective, the application environment, kind of all the components there are with AWS, and take some of the little bits that we got out of the future state architecture and kind of think about how, as we went through the process, you may want to consider other kind of capabilities, like consider more serverless capabilities within your application to take advantage of the AWS platform and to help control the costs for your application when the customer is running it. Of course, we'll do all the work to make sure that your team knows the designs that went into it. We typically do this on an ongoing basis throughout the process so that your team is always feeling comfortable about the code that we're writing on your behalf, that you understand what it is, and making sure that it's well documented so that your development team can understand what's going on. And we'll integrate with any one of the source control tools that you may use, whether it's the AWS code tools or GitHub or whatever it happens to be. We'll help you integrate there. And then finally, on the post-production support, and this goes back to kind of that third thing you need to work out as an ISV, is developing that practice for the upgrade and migration, is the post-production environment. So one of the things that we offer is kind of this managed service to kind of help you along after that application, to help you maintain it, and also provide our insight with developing applications on the AWS platform for how you might want to look at new enhancements to your application. We have an extensive development team that has developed apps on the AWS mobile platform, for example, and we can talk about how you can take advantages of those features for, say, any mobile solution. So we offer this whole variety of things as part of this 12-step process. Now, when I talked about the developing a practice for the upgrade and migration service to your customers, this is kind of the journey map that you'll do probably for each one of your customers. And as you get better over time, you'll compress the time that it takes to do these migrations. But you're going to have to think about things that when the customer is deployed, okay, I see they have this much data or they're using this much compute on their system. How do I then translate that to what's needed on the AWS system? So there is this notion of, yes, we've got to think about where they are now to get them to the new place. And as I mentioned before, if they're running an on-prem solution with servers, such Windows servers or Linux servers, we have tools to help understand their specific workload and monitor that for, say, a couple of weeks, and then use that as the foundation to help you right size when you deploy their environment on the AWS platform. Of course, there are ways we can do the database migration when you think about it for the upgrade process. We know how to automate the schema conversion tool and the database migration service through the AWS command line interface to actually deploy scripts on the customer's behalf to do a lot of the migration heavy lifting. So what you can do is essentially develop a very specific set of scripts to start out with, and then fine tune them as you're going. And this is kind of part of your continuous integration. And as you find newer things that you can automate, you can build that into the migration process, leveraging the tools, and then follow up with some cleanup processes using some other technology, say maybe with Lambda or AWS Glue. When they do the conversion as part of the customer acceptance testing and things like that, obviously you do want to have a process as part of that practice for doing the upgrade and migration to your customers is create that acceptance test criteria so that the customer can feel good about signing off on that. In addition, we have a tool at DB Best called the Database Compare Suite that actually allows you to compare the schema and the data afterwards on the target environment, so you can be assured that all the data actually made it over there. All too often, I've seen well-established development teams do something like, okay, on my target, I had 1 million rows. And so I'll just select count star from that table and compare the count of those records on the destination. If they're equal, we're all good. A lot of times, though, in database migration, that may not be the case, especially since data types, say on Oracle versus the data type on Amazon Aurora Postgres are going to be different. Our database compare suite allows you to actually build this into your process. We have a command line interface that you can integrate into your DevOps environment where you can actually do this throughout the whole process of your migration. And then finally, there's the whole implementation and deployment rollout for the customer, where you're going to want to think about, okay, how do we make sure they have the right monitoring in place? Do you have a trouble ticketing system in place that can integrate in the AWS environment and be able to spin that up? I guarantee you, the first few of these, when you do the customer deployments, they're going to be rough. They're going to take a hand-holding. And we've seen kind of how these go, and kind of working with us hand in hand in these initial deployments will help you develop that migration factory so that when you're starting to do these upgrades, you're going to get better and better and better. So again, why choose DB Best for your modernization process? With the tools that we have, we believe we can mitigate a lot of the risks that are associated with doing that migration. We have done this time and time again with various vendors trying to move their applications to AWS and showing that we're able to do that. Again, with our advanced automations, our tools like the Database Compare Suite, our database migration platform, and the other tool that I alluded to was this tool that allows us to actually see SQL statements that are being actually executed over the wire. We call that application SQL sniffer. This allows you to help reduce your application risk as well. And so you can actually see SQL statements beyond your application that the customer may have built on top of your database. So for example, they may have some reports built with, say, Tableau or Power BI or AWS QuickSight that are causing issues, performance issues and things like that. And you need to make sure that those will still work on the customer's behalf. And SQL Sniffer will actually help you identify those SQL statements in that process. And again, we've developed native SQL AWS applications, not only for mobile, but for web, Kubernetes, and so on. So we understand the whole environment that it takes. And then finally, we have a managed service to back you up, not only through the continual evolvement of your application and understanding the capabilities of AWS. We have, for example, clients where we have a dedicated developer working with their team to continue to make improvements on their solution within that environment. But likewise, we can offer those same managed services to your customers. Right? And so you can use us with your customers to help them get the most out of their environment, to help them take their applications to the next step on the AWS platform and correctly extend your solutions with their solutions so that your customer can get the most value out of AWS. So how do you get started? It all comes down to a very simple engagement where we do our future state architectural design. This is typically anywhere from a 1 to 2 week process with a team of solution architects. Again, we may consider what I call that mini pilot to help your team kind of understand the technologies that we're going to use with AWS. We can also use this as some initial training to help your staff get kind of understand the AWS platform. But the whole idea here is to kind of understand your current state, where you need to go with your future state, and think those 2 steps, at least 2 steps ahead on, okay, how do we then package that up for delivery to your customer and develop a framework? And that's kind of all around the future state design. And this includes things like deploying your application on the AWS marketplace. Then what we'll typically do is a little longer engagement. This can be anywhere from 4 to 8 weeks, where we take a subset of your solution and essentially we come up with a deployable solution that you can show your leadership team and your customers how this new application is going to work on the AWS platform. And so we try to scope it down so that when we develop this, even though we call it a pilot, we do everything as if it would be production ready code. So we want to make sure that there are always elements of high availability and disaster recovery in that pilot. There's always the right levels of security in that environment, and so on. And in cases where you are wanting to deploy on the AWS marketplace, we'd even include that as part of that pilot program. And then finally, there's the full application migration to AWS with all the refinements, the 12-step process, thinking again also how you're going to handle the upgrade offer for your earlier releases, and of course, helping you develop that practice for upgrading and migrating your customers to the AWS platform. And with that, I thank you very much for your time. I hope you will reach out to us to understand how we can help you migrate your solutions to the AWS platform, and looking forward to having great conversations with you in the future. Thanks.